Sure. So, hi guys. We're gonna just go over area of trapeziums. So let's just start. Let's just get right into it. And let me not waste your time here. So trapezium usually has a pair of parallel sides, and they always give you a perpendicular height between these two parallel sides, right? So that's pretty much important. That's if you're looking at a quadrilateral and it has a pair, like only one pair of parallel sides, you're probably looking at trapezium. And if they ask you to find the area, we can use we can use the formula we're gonna get. So yeah, trapeziums have one pair of parallel sides. So oh my gosh, you can already see it, but just pretend you can't see that. So if you wanted to find the area of the sky, we already know how to find the area of like rectangles, triangles, squares. We know that. That's the basic building blocks. So how can we make this look more like something we know? Well, one way. I'll just show you that this isn't the only way. You can make it this triangle and then this rectangle, but that has some weird stuff when we get to the base of these triangles. So an easier way is if you split up into two triangles. You have this triangle right here, and you have this triangle right here. This triangle has a base of A. This triangle has a base of B, and they both, this is the kicker here, they both have a perpendicular height from the base of H. Right? If you look at the triangle, that's the base, and that's the perpendicular height. You need that height there, and it's just H. That's the height in the formula half base times height. You're looking at the base and then the perpendicular height from the base you're looking at. So if I knew the height from here to here, if I knew that height, I could use that as my base. But unfortunately in this case, don't know that. So if you split it up into two triangles, you have half base times height, half B in your base times H plus half A times H. And then yeah, that's the area of the entire shape, right? The sum of the two areas. That's the area of the entire shape. You can factor out the half H, and our final wonderful formula is half H B plus A. Yeah, and that's it. That is how simple it is. We can even work with this, but this guy is kind of nicer to work with, right? Because can make a triangle here. I'll let you guys do it. Wait, before I even do anything, maybe this can be your short little exercise. Come up with the formula from a trapezium that looks like this, because this guy, the angle here isn't 90 degrees, not 90 degrees. This guy, on the other hand, has these right angles. So does the formula still work? You're probably recalling that you only know this formula, so yeah, it has to work. Of course it'll work. But could you derive a way that could work? You guys can pause the video, I'm not gonna stop myself. So you can, easiest, simplest way, I think. You can still continue, actually, that's not the easiest, simplest way. The easiest, simplest way is the way I just did it. Form two triangles. And this one's just easy, because this is a right angle triangle. Already half base times height plus half A times perpendicular height. It's one thing. That's one thing that always knocks me down. Because I feel like half base times height can only work if there's a right angle triangle, but that's a wrong assumption. Half base times height is the area of any triangle. Any triangle doesn't even need to have a right angle. All you need though is this perpendicular height from the base. Perpendicular meaning it makes 9 degrees at the base to the tippity top of the triangle. And yeah, that's it right now for area of a trapezium. You need to remember this formula, and I think I might find an exercise and post it on the channel. Sure, thanks guys.